Okay, so let's go to the next subtopic, still under radioactivity, half-life. Now, what is half-life? The half-life is defined as the time taken for half the initial amount of a radioactive substance to decay. That is half-life. So these are the parameters we are going to use. So without wasting much time, we just go to our first question. And before we do, T half is the half-life. T is the time taken. K is the disintegration constant. N naught is the initial amount. N is the final amount. Good. So how are we going to treat this? So we are going to deploy these parameters in order to get the solution to this question here, right? So the half-life of a radioactive substance is 1,620 years. How long? Now, when they tell you how long, what are they looking for? That is time. How long will it take 100 grams of the substance to decay to 25 grams? The best thing for you to do is to list your entities out. So the half-life is given. That is 1,620 years. And the initial amount also given. That is the N naught, 100 grams. Because we were told, will it take to decay to, that should be a final. What are we looking for? How long? How long happens to be what? The time, T. Good. So looking at parameter or formula number 1, I can use that because I know my half-life. I can get my disintegration constant, that is a K. So I'm going to use this using T half equals 0.693 over K. Now the half-life is 1620 years, 0.693 over K. Now when I cross multiply, I have K this way with this under. Now, what is the disintegration constant? Guys, what do you get? So that is the disintegration constant that we are getting. Good. That is K. That is K. So we want the time, not K. We need the time and not K. Good. Okay. So I have K. I think so. We will use this parameter number 2 here, so that we have this, we have that, we have K now. We can get our T. Good. Now, what is the difference between this formula number 2 and formula number 3? They are the same. You see, this natural log is equivalent to what you see here. So natural log means 2.303 log. Full stop. Natural log 2.303 log. When do we use this? In fact, there are certain times that you have this, you don't know this, and you don't know maybe T. You cannot punch an alphabet on the calculator. It's not going to work. So in order to make it easy, this thing is quantified like this. So we use 203 log. So when I punch natural log of 100 over 25, it's the same answer as punching 2.303 log 100 over 25. So you can check and see. Natural log of 100 over 25 will give you the same answer as punching 2.303 log 100 over 25. Okay? So we will see questions where we have to use this formula and not this. So you can go natural log initial over final equals what? KT. Now natural log of 100 over what? 25. K is what? 4.278 power minus 4. Or by T. You see, I don't know T. Now punch natural log of this. What did you get? Natural log of 100 over 25. Okay. So what are we getting here? So we have natural log of m naught over n gives us 1.386 equals this. So I just have to divide through by this coefficient of t here. Divide through same. So you'll be getting 3240 years equals t. So that is what the answer will look like. 3240 years equals t. So that is how long it took. 3,240 years. Okay. The half-life question, and we had a time to be what you saw. So what if we don't know any formula concerning half-life? Or can we solve half-life without a formula? That is very true. So there is a relation linking half-life and fraction length. A fraction length has to do with the final amount or initial amount. Fraction length after decay. So I'm going to show you something using this parameter to solve half-life. Now that is one of the formulas that you can just use to solve half-life without even writing anything. You can just look at it like this. Using I expression, you can even tell the answer without writing anything, going through the natural log and all those things, right? Okay. But maybe the only challenge is that if the figures are complex, very big, like thousands is 120, so then you have to do some computation. If you are very simple, like 8, 10, you can do them without even pointing the calculator. So let's look at this. A relation relating to half-life to fraction length is 1 over 2n equals fraction length, where n is the half-life. Now, let's use this to solve the same question again, right? So I'll show you how to manipulate it. It's the same formula you use in finding half-life. It's the same formula you use in finding the time as well. You just need some simple manipulation, right? Now, let's go. Alternative. Using fraction left approach, right? Okay. So let's go. We have 1 over 2n equals fraction length. 1 over 2n equals fraction length. Now, 1 over 2n equals final over initial amount. That is what we call the fraction length. Final over initial amount, right? Okay.